In this video, I'll be replacing the power window switches on a late model Porsche 944, as well as discussing some common issues with power window repair. For the later 944 model years, from 1985 and a half to 1991, the power window switches are mounted on plastic switch covers that are affixed to each door panel with two Phillips head screws from below. The driver's side panel features two switches, one for the driver's window and one for the passenger's window, along with a single joystick for the power side mirror controls. The passenger side panel features one switch to operate the passenger's window, but it's otherwise mounted in the same way as the driver's side. Included in the electrical circuit is a 30 amp fuse listed as window winder at fuse number 4, as well as a power window relay at position G7 on the central electrical panel, which activates when the ignition switch is turned to either position 1 or 2, thereby providing power to the window switches. To better understand this circuit, here's an overview of how the components work together. Battery voltage passes through fuse number 4 and over to terminal 30 on the relay at G7, so if the fuse is blown, the relay won't activate and neither window will operate. The fuse can easily be removed and tested for continuity. However, if one window operates and the other does not, that's also an indication that the fuse is good. Relay terminal 86 connects to the ignition switch, which activates the relay when it's turned to either position 1 or 2. Terminal 85 goes to ground, and terminal 85B leads to the door contact switches inside the door jambs. When the ignition switch is turned from position 1 or 2 back to position 0, and the doors are closed, the power window relay remains active so the windows can be raised or lowered as a courtesy feature. When either door is opened, the door contact switch engages, which deactivates the window relay and thereby terminates power to the window switches. That being said, the door contact switches can fail over time and create a parasitic draw on the battery, as the relay remains active after the car is left sitting. So if the power windows continue to function with the door open and the ignition in the off position, that's a sign the contact switch should be cleaned or replaced. Finally, when the relay is active, terminal 87 sends power to the driver's side door wiring harness and to the window switches by extension. As is the case with the power window fuse, if the power window relay is bad, neither window will operate. So if one window operates and the other does not, that's an indication that the relay is good and the failure would reside in either a window switch, the wiring, or a window motor. If there's no window function from any of the door switches, inspecting the window fuse and the relay is a good place to start. Once the fuse checks out okay, power to the relay can be confirmed by testing for battery voltage on terminal 30. If terminal 30 has power and you suspect the relay is bad, the relay can be removed and a jumper wire applied across terminals 30 and 87 to power the window switches. With the jumper installed, the ignition switch does not need to be turned on to test the power windows. And if this restores the window functionality, the relay should be replaced using part number 944-615-11601, where new units can be found for around $30 a piece. However, if the windows remain inoperable, the relay can be reinstalled and we can move on to testing the wiring and the window switches. To access the window switch connectors, the switch cover can be removed from the door by removing the two Phillips head screws at the bottom of the plate. These screws have the tendency to loosen up over time, and it's not uncommon for some screws to be missing entirely, where replacements can be found under part number 900-143-01602, but any 3.5 by 16 mm panhead screws will work as replacements. With the screws removed, the switch plate can be pulled out from the metal retaining clip on the upper section of the door panel. From here, the switches can be released from the plate by depressing either one of the two locking tabs on the top or the bottom of the switch. Be careful here as the plastic becomes brittle over time and can easily break. With the switches removed from the panel, they can now be separated from the electrical connectors by releasing the 4 small tabs on the wiring harness, 2 on top and 2 on bottom. A flathead screwdriver can be applied below the 2 tabs on each side to release them at the same time. Once the locking tabs are fully released, the switch can be separated from the connector. To test the wiring and the electrical connectors, we'll first turn the ignition switch to the on position. With the wiring facing up and the connector facing down, the terminals are numbered 1 through 5 as follows, with pins 2 and 5 on the left side and pins 4, 1, and 3 on the right. Using a voltmeter applied to the switch connector and a known good ground connection on the car, we'll test for battery voltage from terminal 4 to ground and again from terminal 5 to ground. Where pin 4 connects the switch open position to the window motor and pin 5 connects the switch closed position. Battery voltage at these terminals verifies that the power supply and the wiring up to the window switch is in good shape, and indicates the failure lies in either the window switch or the window motor. Next, we'll test the window switches for continuity using an ohm meter as follows. Looking at the back of the window switch in this orientation with pins 4, 1, and 3 on the left and pins 2 and 5 on the right, pressing the switch up is the window closed position and pressing the switch down is the window open position. While taking these resistance readings, keep in mind that most basic digital multimeters don't provide very accurate results below 1 to 2 ohms. accounting for some resistance in the leads and the meters themselves. For example, with this meter set at 200 ohms and the two leads touching together, we already have a resistance of 0.2 ohms, so we'll need to subtract that from the values we see on the switch contacts. Let's first test the switch open position. When the window switch is depressed in the open direction, we should see a low resistance reading of less than 1 ohm from terminals 1 to 4 and from terminals 2 to 3. In this case, we're getting about 0.4 ohms, and if we subtract the meter baseline of 0.2, we have 0.2 ohms, which is within specification. The same goes for the window closed position. When the window switch is depressed in the closed direction, we should see a low resistance reading of less than 1 ohm from terminals 2 to 5 and from terminals 1 to 3. If you're not seeing continuity here, or if you're getting a significantly higher resistance reading, the window switch is faulty and should be cleaned and repaired or replaced with a new switch. As a side note, because the two passenger window switches are wired in series, both passenger window switches need to be installed and functional for the passenger window to work. So in the case where the driver's side window is working correctly and the passenger side isn't, either the left or the right passenger switch could be faulty, and both should be checked. The majority of problems with the window switches are usually the result of dirty contacts or worn internal components, and oftentimes the window switches can be disassembled, the contacts cleaned, and the switches reassembled to restore their functionality. You'll notice that the window switch terminal block on the back of the switch is secured by 4 tabs, 2 on each side, and they fit into these rectangular detents in the switch housing. The terminal block can be released from the switch housing by first inserting a razor blade or a small flat-tip screwdriver between the plastic housing and the side of the terminal block. Next, another flat tool can be placed within each detent and gently levered back to push the terminal block away from the housing. With all 4 tabs released, the block can be removed and the switch internals revealed, where they commonly fall out and scatter across the floor, so just make sure you're working with a flat, clean surface. Although it's not necessary, this switch button can also be removed by gently inserting a flat tool behind each side of the plastic to release it from the tabs, and now we can get a good look at the internal components. Inside the switch button are 2 hollow plastic cylinders containing metal pins that have a spring on the inside and a bearing ball on top. These bearing balls can easily fall out as well, but are just as easily put back in place on the pins, provided they don't get lost. As for the terminal block, we can see where the pins pass through to the interior, where there are 6 contact points inside the switch, and 2 curved metal contact plates that sit within pivot points at the center of the block. The bearing balls rest at the center of those pivot points with the switch button in the neutral position, and when the button is depressed, the metal pins and bearing balls slide up or down to engage the appropriate contacts to power the window motor. As you can see with this switch, the plates and contacts are pretty dirty, so we'll just clean all these up with either some contact cleaner or isopropyl alcohol applied to each surface. A small file or some fine grit sandpaper can also be used to remove any larger deposits. And with everything cleaned up and inspected for damage, the switch can be reassembled. Now that we're ready to rebuild the switch, we can apply a very small amount of lubricant or grease to the bearing balls, which will smooth out the switch button operation and help keep the balls in place on the metal pins during reassembly. If the switch button has been removed, that can first be reinstalled on the switch housing with the pins facing up to ensure the bearing balls remain in place. Once the metal contact plates are back in position on the terminal block, the block can be joined with the switch housing. Here we'll just find the best angle where all the switch internals stay in place, but with the switch plates facing up or slightly to the side typically works best. And once everything is lined up, the new terminal block can be pressed back into place. With the switch reassembled, it's a good idea to check for smooth operation of the switch button and retest the switch for continuity. Once everything checks out, the switch can be reinstalled and tested on the door panel. However, if you determine the switch cannot be repaired, new switches can be found under the original part number 951-613-13300 or the superseded part number 951-613-13302. Where the OEM switches are available for about $100 and the aftermarket ones for around $30. As for this 944, the internal components for the passenger window switch on the driver's side had recently jammed up, and the window close function no longer worked on this side. The white triangles on the driver's window switch are also a little bit faded, so I decided to replace that one as well. After disassembling and cleaning the passenger window switch, I was able to restore its functionality for both up and down window movement, and a replacement driver window switch has been connected as well. At this point, the window switches and the cover can be reinstalled on the door panel in the reverse of removal, and you'll have successfully repaired the power windows on your Porsche 944.